Hello, students. Very good afternoon, all of you. How are you? So, 11th class is going on. So, we are studying about organic chemistry, right? So, in NCERT, it is given as organic chemistry, some basic principles and techniques. So, in that, we have studied IUPAC nomenclature, how to name a newborn baby. So, we have studied that. So, you can name any baby after this. Then, second, we have studied GOC, electronic displacement effect. Okay, then isomerism also in between Sanjita sir has completed, right? So today we are going to continue that one, right? So first of all, I'm launching the technical poll for you. I have launched a technical check for you. If everything is fine, then give the positive response. If there are any technical issues, let me know. Then we will resolve that and we will start the class without wasting any time. Okay, so you two friends, you can give me the response in the live chat section. Okay, so you two friends, you also have to participate. Okay, then only it will be interesting for us. You can tell the name of the JNB from which you are. Okay, okay, so students are joining. Great. I think from Shillong region. Great. I have launched a technical check. I hope everything is fine. So I am ending the poll here. So in the last class, we have studied about what? We have studied about resonance, right? So resonance, what is resonance? In chemical bonding, actually, you have studied the resonance. So we are studying it for the second time. So it will be very easy for you, right? So a question for you. So we have studied, we have to recall what are the things that we have studied in the last class. So this is a question for you based on last class. If you have attended the last class, it will be pretty easy for you. Otherwise, you have to revise the things. Okay, then which structure? They are all resonance structures, right? So which one has more stability? So class 11 means which JNB? The JNB name, can you tell the name of the JNB? So these are the four cases. So what are the points? So try to recall the points that we have studied. So here, first point, if it is polar, if it is non-polar, if charge is present, if there is no charge. So charge more means stability less. If there is no charge, stability is high. So which structure has no charge? That is more stable. So A, C, B, D, right? So we have A, the structure A we have. So it has no charge present. So it is more stable in nature. That was our first point. So what about the next point? So charge. If charge is present, what we have to check? If negative charge is present on more electronegative atom, then it is more stable. So let us check it here. Here carbon is present on carbon negative charge. No. It is not that much stable. Then here we have oxygen. Oxygen and carbon. Who is more electronegative? That is our oxygen. So negative charge on oxygen. So this structure will be more stable. So first one A, second is our D. Then B and C. What about B and C? Positive charge is present on nitrogen, negative charge on carbon, right? Dissimilar charges, opposite charges are present. So our next point is if opposite charges are close to each other, then stability is high. So look at here. So plus and here minus. Here plus is here, minus is far away from that. So it has least stability. So B is next one. Last one is our C. So these are the different options. So first one, neutral. Neutral has more stability. Then what about the second point? More electronegative atom. It should get negative charge. Then our resonance structure is more stable. Then next point, that is charge. charge will be close to each other, dissimilar charges. Then that structure will be more stable. These are the points that we have discussed in the last class. So the correct option A, then D, then B, then C. So this is a correct option about the resonance structures, the stability of resonance structures. So if you have not attended the last class, then just go through that video, study that. Okay, that's all. Then one more question. Recall question. What is that? So again, need previous year question. So what is the hybridization state of benzyl carbonium ion? Carbocation. We have studied carbocation plus, right? So you have to tell me the answer. So you have to tell me the answer here. Okay. So I will launch the MCQ poll. A, B, C, D. So which one is correct option? So which is a correct option here? Yasmin. It is for Yasmin. This question is for Yasmin. How to find the hybridization? So fast, fast, fast. Only 30 seconds for you. Within 30 seconds, you have to answer this question. So you two friends, you can also answer. Okay. So I have launched the MCQ poll. In that, you have to click A or B or C or D. You know that, right? So fast, fast, fast. Or maybe you're sitting there and you have to go to the system and click the. That is why it is taking some time, right? So do it fast, 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 fast. So only 10 seconds for you. So I will end the poll within 10 seconds. So do it. So how to find? How to find? So we have positive charge. We have positive charge. So we have to find the hybridization of this carbon atom. How to find hybridization? That is equal to number of sigma bond. Number of sigma bond plus number of lone pair. Number of lone pair. There are different equations you can use. You have studied it in chemical bonding. So count the number of sigma bond. Here C, then 1H, 1H, then there is a plus charge. Then can you tell me how many sigma bonds are present here? How many sigma bonds are present here? In the chat box, you can give me the answer. Hey, I have launched the MCQ board. You have to click there. Then only I will understand whether you got the point or not. So here I can see first sigma bond, then second sigma bond, third sigma bond. So hybridization that is equal to 3. 3 means our hybridization that is sp2. So this carbocation that is sp2 hybridized. So if it is 4, if I'm getting H is equal to 4, that will be sp3. Okay, you have already studied. So for this question, A is the correct answer. Okay, I'm ending the poll. In the next poll, you have to participate. Okay, so this is another recall question for you. What is the hybridization state of benzyl carbonium ion? So we have studied about carbonium ion, our carbocation. So sp2. I hope that is also clear to you. Then next one, one more question for you. Homework question. So what is the correct answer for this homework question? Okay, JNV Srikakulam, they are back. Kolhapur, Karimnagar, Daman, then Shillong region. Okay, from Shillong region, there are a lot of students. Great. So what is the correct answer for this homework question? Last day. Okay, if you have attended, then you will, of course, you will get it. So what is the correct answer for this one in the chat box? Chat box, it is open for everyone. So you can give me the answer in the chat box. What is the correct answer? This is based on hyperconjugation. So free radical, we have studied homolytic cleavage. Then free radicals will be formed. Yeah, correct. JNV Srikakulam. So whenever JNV Srikakulam students are attending the class, of course, they will give the answer. That is sure. But last year, I couldn't see JNV Srikakulam. Maybe in U2, you might have attended. So CH3, CH2. So what you have to check? The number of alpha hydrogen. More number of alpha hydrogen, more is a hyperconjugated structures. Then more is a stability. So let us check. JNV Srikakulam is saying B option. So let us check that. So here, this is our free radical. This is alpha carbon. Then there are 3 alpha hydrogen. So first one, there are 3 alpha hydrogen. So we are considering the B option. Then first, second free radical I'm taking. This is free radical. Then alpha carbon. Then the hydrogen attached to that one, alpha hydrogen. So total there are 6 alpha hydrogen. Then I'm taking this one. What is that one? Then free radical, CH3, then CH3, then this side there is a CH2, then CH3. So alpha carbon, alpha carbon, alpha carbon. So alpha hydrogen 3 plus 3 plus 2. So that is 8, right? So 8 alpha hydrogen. So what about the last one? Last one. This is the last one. So there is free radical. Then CH3 group is present. Here also CH3 group. Here also a CH3 group. So how many alpha hydrogen? 3 plus 3 plus 3. So 9 alpha hydrogen. If number of alpha hydrogen is high, then stability that is also high. So the correct option for this previous year question, that is B. So while studying the concept, we are also solving some questions. This is entrance examination, competitive exams, right? So we have limitation. For what? So to practice more number of questions in the class, we will do it. Then it is your duty. So we will do some questions. Then after that, you can go through the reference material, then do the problems. So this is a homework question that is also done. So YouTube friends, I'm not getting response from YouTube friends. Okay, so let us start the topic. So let us start today's topic. You have to respond actively, like JNB Srikakulam students. So mesomeric effect or resonance effect. So we have to study about that. This is also an electronic displacement effect. There is movement, displacement for the electron. So that is causing something for the molecule. So we have to study about that. So what are the effects of mesomeric effect or resonance effect? So we have studied resonance effect. What is this mesomeric effect? Same, almost same. There is displacement of electron in the molecule. So electron is moving from one place to another, displacement. Okay. Then due to resonance, there is displacement. So that is known as mesomeric effect. So one more definition for you. So whenever any group creates a charge separation between itself and a conjugated system through resonance, that is known as mesomeric effect. Oh, quite difficult, right? So let us take an example. So we will take an example. We have CH, double bond CH, then this one. Okay, then one group is attached. This group has some lone pair of electron. Then what will happen? Lone pair, it is a rich guy. So it will give electron to this one. So electron is given. Then carbon tetravalent. So if this electron is given, new bond will be formed. So carbon will become pentavalent. So this bond should be broken. So that is broken. So what is the charge developed here? This X atom, lone pair, it is giving money to someone. So it will get positive charge. Then this carbon, it is taking money. Money means electron. So it will get negative charge. So positive, negative. There is charge separation due to resonance. Last class we have studied pi, sigma, lone pair. If there is pi, sigma, lone pair, then there will be resonance. So there is resonance happening here. Okay, then I am getting, so this is me. Okay, this is me. This is my friend. Okay, this is my friend. So my friend is giving some money to me. So I am getting a positive impact. So I can call it as plus M or plus R effect. M means mesomeric. R means resonance effect. Almost same, but the definition that is given, it is unidirectional. This mesomeric effect, that is directional. So from here to here, I am getting some money. So what about this one? Minus M or minus R effect. Same example, I'm taking CH double bond CH, then CH double bond CH. Then I have a group. Okay, so this is our group. Then attached to that one, there is a double bond. So I'm taking oxygen atom. So this is our group. This is our group. Then one condition, Y and oxygen. That is the atoms present. So this oxygen, that should be more electronegative. This is not X. Okay, this is chi. So electronegativity of oxygen should be higher than electronegativity of our Y atom. Then what will happen? Electronegative. That means he is a villain. So he will take the money from this bond. So it will get negative charge. It is taking money. So I can say negative charge will be formed on this oxygen. Then valency, this pi bond will be jumping to this position. So pi bond is going from this carbon, it will get positive charge. So positive, negative charge separation is developed. So in this direction, it is going, electrons are moving due to resonance. So this is known as mesomeric effect. So plus M, minus M. So what is happening here? So this is me. This is my friend. Okay, I am a poor guy. So my friend is he is taking money from this poor guy. So it will ultimately create a negative impact for me. So that is why I can call it as minus M or minus R effect. So this is mesomeric effect. Due to resonance, there is displacement of electron. Then there is a charge separation between the groups. So that is known as mesomeric effect or R effect. There are two types, that is plus, there is minus. Okay, me and my friend, we have to remember. Then we have to check the examples for plus M or plus R. Okay, so what is happening? So some guy is there, he is giving electron to carbon chain. So I am the carbon chain, positive effect. So donates electron. My friend is donating electron to me. So it is a good guy, right? So donates electron to the carbon chain. So how can it give money to me? It should be rich. So lone pair, electrons are present. So that atom should contain lone pair. He should be rich, then only he will give money to me. So that is a point here. So here I have the friend, he is very rich. Why? There is a lone pair present here. Then he will give money to me. So what is happening in the next step? So he is giving money to me. Then pi bond is present, carbon tetravalent. So in order to maintain the valency, this pi bond will be shifted. Again, charge will be formed, a resonance. So this example we have discussed in the last class. So what is happening here? There is pi bond, there is sigma, there is lone pair. So if there is pi, sigma, lone pair, resonance possible. Which are the other condition? If there is pi, sigma, pi, then also resonance possible. So look at here. Here we have pi, here we have sigma, here we have pi. So how to identify the resonance? Pi, sigma, lone pair, resonance. Pi, sigma, pi, resonance. There are other conditions also. We have discussed that pi, sigma, positive charge, resonance. So pi, sigma, negative charge, that is also a chance for resonance. Then pi, sigma, heteroatom like oxygen, nitrogen, they have lone pair also, octet is also completed, right? So these are the different possibility for a resonance. So if you get a molecule, we have to check if there is pi, sigma and lone pair close to each other, then chance for resonance. Then you have to check the direction of resonance. In which direction electron movement is taking place, displacement of electron is taking place. So plus M effect, right? So plus M, I'm getting a positive impact. So I have a very good friend. So what about this friend? This is my friend OH. He is rich. Rich means lone pair is present. So he will give. So this is me, right? So this is me. So he will give money to me. Then what will happen? So he is giving money to me. Then some bond, new bond is formed between me and my friend. Oh, he's giving money, right? So strong friendship. So then this bond, this pi electron are shifting. So this oxygen is giving electron. So what will be the charge form? That will get positive charge. Then our carbon, this pi electrons are shifting and this carbon is getting electron. So it will get negative charge, positive, negative. Charge separation is developed here. Then again resonance, right? So we have negative charge. What is happening here? Here we have a negative charge. Here we have sigma. Here we have pi. Again, chance for resonance. Then this negative charge or electrons are coming. Then next pi electron should be shifted. So this carbon is getting some more electrons. So negative charge. So negative charge will be formed again. So what is happening? So negative charge, sigma, pi, again resonance. So negative charge, it is going, electrons are going. Then carbon tetravalent. So pi electron should be shifted. So this carbon is getting some electrons. So negative charge on that carbon. So negative charge on this carbon. Then what is the final step? Then again, negative charge, sigma, pi. Again, resonance will take place. So it is going to this position. Then pi bond is shifted to oxygen. Okay. So this is the final thing. So first one and last one. We are getting so many resonating structures in between. That is a point. Okay. So charge separation is developed. Here OH, it is giving electron to the ring carbon chain. So we can call it as a plus M group or plus R group. Is that clear to you? So in the chat box, you have to reply. Is that clear to you? Me and my friend, my good friend. So positive effect. Kolhapur, Daman, Nikhil, Shafi, Sanjeev, JNV, Kolhapur, Alima is here. Alima, is that clear for you? Me and my friend. So how can you identify resonance? Okay, JNV Srigakulam students. So condition to identify resonance. Yeah, great. So I'm getting positive response from JNV Srigakulam, then Alima. Okay, so others should also respond. So this is our positive M effect. So what is next? So we should study about minus MF8. So what is happening in minus MF8? So we have to study about minus MF8 next. So what is happening? So me, my friend Anna is a very wrong guy. So he's taking all the money from me. So I have only 1,000 rupees in my bank account. Still he is taking money from me. Okay. So negative impact on me. So that group, he is a villain. My friend is a villain. He is taking all the money. So withdraws electron from the carbon chain. So what is the condition? For plus M, what is the condition? There should be lone pair. It should be electron rich, then only it can give money to me. Here, what is the condition? Attached atom has pi bond with more electronegative atom. Electronegative. So electronegativity will let. Okay, he will take the electron. That is a point. So we have to consider this one. So we have this group A, D. A and D. D is more electronegative. So it will take the electron from this bond, pi bond. Okay, then we have to satisfy the valency. There will be shift in the pi electrons. Shifting. We have discussed this condition already. That is why I'm not again repeating the thing. Okay, this is happening. Our group is taking electron from the ring. That is known as minus M group. Example for you. So this we have studied NO2 group, NO2 group. So NO2, what is happening? Nitrogen and oxygen. There is a different kind of arrow. What does that indicate? There is an arrow here, right? So this is an arrow. Here normal double bond is seen. So what is the difference between these two? That arrow indicates what? What is that? Abhinav, Adityan, then Sanjeev, Nikhil Shafi. So what does that mean? That arrow. So that means it is a coordinate bond. This nitrogen is giving electron, 2 electron. So it is giving the electron to oxygen. Then there is a bond. So in that bond, nitrogen is giving 2 electrons. So we can call it as coordinate bond. As nitrogen is giving, it will give positive charge, right? So nitrogen positive. That is due to the coordinate bond. Then we have the villain here. So our villain, that is our oxygen, electron negative. So what will happen? So our villain, it will take electron from this pi bond, right? So it is taking electron. Then nitrogen is here. So nitrogen want to satisfy its valency. So it is asking our benzene ring, this phenyl ring to give some electrons to me. So this pi bond is shifted. Then it will reach here. Then what is formed? A double bond between nitrogen and this carbon. What about oxygen? One pi bond is broken. It is getting electron. So negative charge, right? So negative charge is formed. So again, resonance will happen. Why? Here we have a pi bond. Here we have sigma. Here we have positive. That is a condition for the resonance. Why positive charge here? Because this carbon, it is losing the electron. So positive charge, right? So next structure. So bond is formed here. Then this carbon is losing electron. So positive charge on that carbon. Again, we have positive sigma, we have pi, again resonance. Then movement of electron, displacement of electrons will takes place. Then again, positive charge on this carbon atom. Then what is the final step? What is the final step? So final step. So I will show you the final step. This double bond, it is vanishing. Okay, so that is coming back to this one. So double bond will be formed. Then nitrogen, oxygen. Oxygen is giving back the electron to this nitrogen. So nitrogen, oxygen. So double bond is formed. So it is coming. So nitrogen has to satisfy the valency. Then oxygen is saying that, okay, nitrogen, no issues. I will again give you the electrons. We will make the friendship again. So that is happening here. So final structure. So first one, in between, we are getting so many resonating structures. So what is happening here? We have a group. In that, there is oxygen. He is a villain. He is taking the electron. The nitrogen is saying to the ring, so I need some electron. Okay, I need some money. So give me some money. So electrons are going away from the ring, our carbon chain. So we can call it as NO2 group as a minus M group. Okay, or minus R group. So you have to check if there is pi bond in the group, then minus M. If there is lone pair for the group, that is a plus M. Then one more thing. This is our functional group. So this is the first carbon. This is also first carbon. Okay. This is our functional NO2. That is a functional group. With respect to that, I am taking this carbon and this carbon same, right? Okay. So that is known as ortho position. That is known as ortho position. Then I am coming to next carbon 2. This side also 2, right? So 2, 2. That carbon, So that position is known as a meta position. Okay. Then third one, this is a third position. That is known as para position. That is known as a para position. Okay. Then observe this one. So, okay, Jervis Srigakulam, right. So observe all this resonating structure. Positive charge is present at which position? That is a question for you. There is ortho position, there is meta position, there is para position. So positive charge in these resonating structures, positive charge is present in which of the following location or positions? Ortho, meta, or para. Okay, this is also our ortho. This is ortho. So fast. This is ortho. So this is ortho. This is also ortho. So meta. This is meta. This is known as para. So positive charge is present on which of the following positions? Ortho, meta, para. So JNV Srigakulam, okay. So meta position is a positive charge. Can you check it once more? Alima, yeah, right. Para position, there is positive charge. Then one more position, right? Ortho or meta. So observe the resonating structures. So in which of the following positions a positive charge is present? Positive charge. So one is para, that is confirmed. Meta, I can't see any positive charge in our meta position. So that is ortho, O and P. That is ortho. This is ortho position. This is our para position. This is also ortho position. Yeah, JNV Srigakulam, correct. Meta. Okay. Advanced level. Great. So ortho and para, there is positive charge present here. Great. So these are the different groups showing plus M or plus R effect. So in the question, you can go for lone pair. If lone pair is present, most probably plus M. They will give electron to the ring. That is a first point. Okay. Then what about the group showing minus M or minus R effect? That is NO2, that is nitrogen, then oxygen, that is more electronegative in nature. There is double bond between nitrogen and oxygen. Then we can say that group will show minus M or minus R effect. So these are the different groups. We have already studied about all these groups. Where in IUPAC nomenclature, we have studied about, okay, all these one. Okay, Binod. Okay, Binod OP, then RVD GFX. Okay, in YouTube, some students are commenting, good afternoon. Okay, good afternoon. We know this also there in the YouTube. Okay, fine. Then, so these are the different groups. You have to notice that we will practice some more questions also. So lone pair, then a double bond. There is an electronegative also. Here it is NO2, oxygen, then pi bond is present. So that is mesomeric effect. So mesomeric effect acts only at ortho and para position. So we have discussed plus M, we have discussed minus M. So negative charge, ortho para, then positive charge. We have observed that which are the positions in which positive and negative charge is present. So point is M effect, it's present at ortho and para position. So M effect, or I can say resonance. So if there is meta position, if a group is present in the meta position, it will not show resonance effect. So we have explained based on the charge, okay? We have explained based on the resonating structures. So this is a very important point to solve the questions. So meta position, nothing. Ortho para position, it is there. So it is very important. These are the different groups showing mesomeric effect. So which are the applications of mesomeric effect? Again, stability of carbocation, stability of free radical. We have explained this based on first, our inductive effect. Second, based on hyperconjugation. Third, we are explaining the stability again using mesomeric effect. So what is happening here? Let us check it. So stability, carbocation, R plus, free radical, R, then there is a dot, right? So they're electron deficient. So electron deficient means they need some money. So they are poor guys, they need some money. So if some people is coming, some friend is coming and it is giving money, then it's fine. So stability that is proportional to 1 by electron deficiency. Or I can say stability that is proportional to plus M. Plus M means that group will give electron. That means electron deficient species, it is giving electron, then octet possible. So free radical will be more stable. That's the point. So how to remember? R plus. So plus charge. So carbocation stability proportional to plus M. Free radical stability, same as that of carbocation. It is also directly proportional to a plus M effect. Okay, so we have to check it. Okay, if it is directly proportional to plus m, what about minus m? So they are electron deficient, they are poor guys. So one man is coming, one friend is coming, it is taking the electron money from that poor carbocation. Then the stability of the carbocation will decrease, stability of free radical will decrease. So what you have to check? If there is group showing plus m, then stability of carbocation will increase. So this is a question for you. So you have to give me the answer in the chat box. Compare the stabilities of following free radicals. So how to check the stability of following free radicals? You have to check the group attached. If resonance is possible, then stability will be increased. So let us check that. First one, only there is a free radical. There is a free radical. Here it is sigma bond. Here also sigma bond. So what is the condition for resonance? Pi sigma free radical, then resonance. So what about this structure? There is no resonance. There is no resonance possible. This condition we have already studied. Then what about this one? Here we have a free radical. Here we have sigma. Here we have pi bond. So I can write pi sigma free radical. So resonance is there. If resonance is present, then stability will increase. Stability increases. Stability increases. So compared to the first one, second one has resonance and stability increase. Then what about third one? So what about third one? We have to check the third one. Is the resonance? Of course, here we have a free radical. Then here we have a sigma bond. Here we have a pi bond. So we can write pi sigma free radical. Sorry. Yeah, that's correct. Pi sigma free radical. So there is resonance. If resonance is present, stability increases. What about this group? This is our CH3 group. So we have our CH3 group. So what about the CH3 group? So it is ready to give electron through plus IFN. So it is also giving electron free radical, that is electron deficient. So CH3 group, it is showing plus I, it is giving electron. So our free radical can achieve the octet, so stability increases. So due to the presence of CH3 as well as the resonance, stability of third structure that is greater than second one. What about the fourth one? There is CH3 group. There is CH3 group present, so it will show plus IFI, of course. Then we have free radical. We have free radical, we have sigma bond, we have pi bond. So resonance is possible, right? Then check one more case. Here we have pi, here we have sigma, here we have pi. That is also a condition for resonance. There is delocalization of pi electrons. So stability will increase. So first case, no resonance. Second case, resonance is present. Third case, resonance plus our inductive effect. What about the third case? Sorry, fourth case, there is resonance due to a free radical sigma pi. Then there is pi sigma pi. So there is extended resonance. Delocalization is increased. So what about the stability order? 1, 2, 3, 4. So fourth one is more stable. Okay. Then third one. Then second one. Then our last one or a first one. So there is no resonance for the first one. Is that clear to you? Application of mesomeric effect. Is that clear? Alima, JNV, Srigagulam students, extended resonance, pi sigma pi, then pi sigma free radical. There are two conditions. Okay, fine, fine, fine. Great, Alima. So one more application. So let us study one more application. Stability of carbanion. Carbanion, negative charge. So electron rich, it is an electron rich species. So what about the charge? If negative charge or any charge is present, then stability is very low. How to increase the stability? We have to reduce the charge. So if charge is there, we have to reduce that. Yes, more money. More money means always tension. So we are good friends, right? So we will take the electron from that one. So that is a case happening here. Stability that is proportional 1 by electron density. So we have to decrease electron density, negative charge. Then only stability will increase. So stability that is proportional to minus m. Why minus m? Minus m means it will take the electron from the carbon chain. That means negative charge will decrease. Then if it is directly proportional to minus m, what about plus m? Stability and plus m, they are inversely proportional. Why? Plus m is giving again money to the carbon chain. So negative charge, that means tension will increase. It will reduce the stability. Okay, that is the application. So question for you. So compare the stability of following anions. So you have different anions present. So stability that is inversely proportional to charge. If some group showing minus m is there, then charge will decrease, stability will increase. So among these 1, 2, 3, which one has higher stability? Can you tell me 1, 2, 3? So we have 1, 2, 3. So which one, Alima? Check it once more. 1, 2, 3. Ajay Srigagulam students correct. So why? We have NO2 group. NO2, nitrogen and oxygen. There is double bond. Oxygen is a villain. He will take the electron from nitrogen. That bond is broken. Then nitrogen will ask the ring to give some electron. Then what will happen? So electron density on this carbon, that will also decrease. So NO2, it is taking electron from the ring. So it will show minus M effect. It will show minus M. Minus M, it is taking electron. So negative charge will be decrease electron density. Carbon, negative charge. Negative means electron. That means electron density high. So this NO2 group will decrease electron density. So we can say the third one is more stable. Okay, JNV Srigakulam, that is correct. Alima, you have to check it once more. NO2 group. So which group is showing minus M effect? You have to check that. In the case of carbanion. So what do you have to check? R minus carbanion. How to remember? Minus charge. So that is proportional to minus M. Carbocation, that is plus charge. It is proportional to a plus M. Okay, so I hope this is clear. So we are discussing the same thing. What? Stability of carbocation, stability of carbanion. So based on inductive, based on hyperconjugation, based on resonance. Suppose we have hyperconjugation, we have a resonance, we have inductive. Who is more dominant? That is stability due to resonance is more dominant. Then after that, you have to check the hyperconjugation. Last, you have to check inductive effect. Okay, resonance stabilization, that is a very high, it is very dominant. Then only hyperconjugation, then only our inductive effect. So resonance, there is delocalization of pi electron. It is getting a more stability. Okay, so that is the application of a mesomeric effect. Second application. Then we have to go for the third one. How to check the acidity of the reagent? This one also we have explained before that. So do you remember this one? Based on the last inductive effect, I think. So we have explained this one also. So acidity of reagents, how to check the acidity of reagents? Who is Sam? Hi, sir. Hi. Hi, Sam. He's asking, who is Sam? Okay, in YouTube. In YouTube, a lot of things are happening. So acidity of the reagents. So what is a good acid or a strong acid? So strong acid means it should release more H plus. Okay. So with H plus, there is A minus also present. That is conjugate base. We have discussed acid, conjugate base. What is the difference between acid and conjugate base? Difference is 1 H plus. You can see H plus is the. Then acidic strength, that is proportional to Ka. Then can you tell me, so what is this Ka? It's an experimental quantity. So how to find the acidic strength? What is Ka? Do you remember what is this Ka? A means acid. K means what is that? Ka means what? So you can give me the answer in the chat box. Okay, I will wait for that one. So acidic strength proportional to Ka. That is more amount of H plus release. Or we have discussed a reactant to product. So reactant to a product is going on, right? If product is more stable, why bond formation is taking place? To attain stability. Why reaction is taking place? To attain stability. So reactant, it undergoes some reaction to form the product. If product is more stable, then that is good. Then reaction will, of course, it will happen, right? In our life also, we are studying hard. We are working to attain stability. So we need a stable life. Similarly, reactant is getting converted to product. Product is more stable. Then, of course, reaction will take place. So in order to check the acidity of reagent, we can check the stability of conjugate base. Okay, that is A minus. Conjugate base A minus. Negative charge is present. Charge and stability, that is inversely proportional. So how to check the stability? If charge is more, stability less. If charge is less, stability is more. Okay, so I have A minus. I have A minus present. A minus present, and I have a group minus M group. Minus M means it will take the electron from the carbon chain. So A minus, it has negative charge. So due to our minus M2, the negative charge on A conjugate base will decrease. So it will attain more stability. Yeah, Lima, JNV Srigakulam, yeah. Dissociation constant of acid or ionization constant of acid. Great. So Alima and JNV Srigakulam students, they are answering continuously. It's a great thing. You have to respond to the questions. Okay. So let us check the answer. Let us check the answer. What is happening? What is happening here? So acidic strength proportional to Ka. So minus M, that is proportional to acidic strength. Okay. Then plus some effect, that is inversely proportional to acidic strength. So to get more clarity, so we have to go for some examples, right? So we will discuss some examples. So compare the acidic nature of the following compounds. How to compare the acidic nature? So we have an acid, it is releasing H plus, one conjugate base is formed. How to write the conjugate base? So remove this H plus, then write negative charge. Remove this H plus, write negative charge. Remove this H plus, negative charge. Conjugate basis form. Then we have to check the stability of conjugate base, right? So negative charge. So if the negative charge is less, stability more. If minus M group is present, then a stability high. Why? It is taking electron. It will reduce the negative charge. So stability increases. So what about this group? So NO2 group, can you tell me? NO2 group, it is present at para position. NO2 group at para position. So it will show minus M effect. So NO2 group will take the electron. So the negative charge on our conjugate base will decrease. So which one is more stable? So this one is more stable. What about this is ortho, this is meta. Is the resonance effect at meta position? No. So there is no meta position. At meta position, there is no resonance effect. You have to remember that point. Ortho and para only. So this one, NO2 group, it will show some effect, right? But not resonance or mesomeric effect. It will show minus I effect. So minus I effect, minus I means it is taking electron. So it will also increase the stability. But what is the more dominant feature? That is resonance. Due to resonance, stability high. Then only due to inductive effect. So third one that is more stable. Then second one. Then here we have CH3. CH3 at meta position. Meta, there is no mesomeric effect. Only inductive effect is present. CH3, it is a good guy. It is giving electron. Giving electron means COO minus negative charge. So it is getting more electron. So negative charge increases, stability decreases. So what is the stability order? So third one, that is more stable. Then second one, then our first one, it has least. So point to remember, NO2 minus MFet if it is present at ortho and para position. If NO2 is present at meta position, then there is no mesomeric effect. We have given the proof for that, right? So only minus I effect. CH3 at meta position, only inductive effect, but it is showing plus I effect. Plus I giving electron. Negative charge increases, stability decreases. Is that clear, everyone? Is that clear to you? The application of a mesomeric effect. Is that clear? So let me know. Is that clear to you? Yes or no? In the chat box, I'm waiting for you. Okay, Alima, fine. Okay, then. So, it's almost time, right? So we will keep it here. So in the next class, that is tomorrow. So tomorrow we will continue the chapter. So, okay, no homework question for you. No homework question for you. So we will continue this in the next class. Okay, then. Bye, students. So almost time. I hope you got the points. So inductive, resonance, hyperconjugation. Resonance, that is more dominant. Then hyperconjugation, then inductive. That's all. So you have to solve more number of questions. Then only you will get good marks. Otherwise, you will study all the theory. But it is a different game. Okay, not the end game. It's a different game attending the entrance exam questions. So you have to practice it. Okay. Abhinav, okay, Abhinav from which JNV, Abhinav? Abhinav from which JNV? Hi, Abhinav. Then other participants, Abhinav, Alima, then JNV Varda, JNV Kadapa, okay, JNV Kadapa, they are attending the class regularly. Great, great, great. Okay. Then I'm ending it here. Okay, then bye. We will see you in the next class. Okay, JNV Mahi students, hi. No response to the JNV Nasik students, Rajkot, okay. Karim Nagar, great, great. All of you are attending it properly. Okay, then bye, students. We will. Okay, JNV Palakkad. Okay, great, great, great. So Palakkad. Okay, Sanjeev Sajal. Okay, then bye.